हमने yesterday जो है gradient of a scalar point function define किया था. पहले scalar point function, vector point function, then gradient of that scalar point function and some properties of the gradient and the directional derivative. ये दो तीन चीजें हमने डिस्कस की थी लास्ट yesterday और उसके corresponding में हमने एग्जाम्पल डिस्कस किए थे. We discuss some examples on the basis of those things. और लास्ट में हमने किया था that is a dot b this. Now next एक आधा एग्जाम्पल हम उसका लेते हैं डायरेक्शनल डेरिवेटिव का. Let us consider the example for the directional derivative. Let us consider the examples of directional derivative. Find the directional derivative of this scalar point function 5x square y minus 5y square z plus 5 by 2 z square x at the point P, that is 1 1 1, in the direction of the line x minus 1 divided by 2, y minus 3 divided by minus 2, and z is equal to be 1. This is the equation of the straight line in 3 dimension. In 3 dimension, it is the equation of straight line. Now let us consider the solution. Our aim is to find the directional derivative of this phi at this given point in the direction of this one. It means in which direction directional derivative is to be determined. In that direction, a unit vector is to be determined first. Solution, and for the directional derivative, gradient of phi is also required. Here phi we have, here phi is equal to be 5x square y minus 5y square z plus 5 by 2 z square x. Consider the gradient of phi. Therefore, gradient of phi will becomes the, that is the, in first one derivative, that is with respect to x, plus j derivative with respect to y, plus k derivative with respect to z. These are the derivative. Then consider the derivative with respect to x of this above mentioned as a 5. That is 5 to the 10, 10xy. And the second term will be vanishes. And for the third term, 5 by 2 z square. And with respect to y, first term that is 5x square. In second term that is 10yz. And for the third one is k into first term will become 0 and second term minus 5y square, and third term will be 5, 2 cancel with this 2, that is 5zx, 5zx into k. Just simplify at the particular point. This is a delta phi in general. Now our aim is to find the delta phi, a gradient of phi at a particular point, that is at P1 1 1. Replace x, y, z, all is equal to be, each one is equal to be 1. That is 10 plus 5 by 2, that is combine 5 2 as a LCM, 10 20 25 by 2, 25 by 2 I, and for the j 5 minus 10, that is minus 5j, and in the value of k, that is minus 5 plus 5, that is 0k. This is the gradient of phi. And this is the one factor to find out the directional derivative. Another factor is the unit vector is to be determined. For that purpose, first you know in which direction the directional derivative is to be determined. For that part, as you know, in the equation of the straight line, the parallel vector from the equation of the straight line in 3 dimension, the parallel vector is this 2i minus 2j plus k. This is the parallel vector of the straight line. It means directional derivative is to determine the direction of the parallel vector of the straight line. So let the direction of the given line is a is equal to 2i minus 2j plus k. Therefore, unit vector is to be determined the direction of this vector A divided by its magnitude, that is 2i minus 2j plus k divided by 2 whole square, 4 plus minus 2 whole square, that is also 4 plus 1 whole square, that is 9, that is 3. That means 2i minus 2j plus k divided by 3. This is the unit vector in which directional derivative is to be determined. Therefore, directional derivative is of phi in the direction of A will become the dot product of these two. One is a del of I, gradient of phi dot with a unit vector in which direction directional derivative is to be determined. Del phi is 25 by I minus 5j dot product with 2i minus 2j plus k divided by 3. In dot product, only the product of I, j, k, k are to be required. Remaining will be vanishes. That is 25 by 2 into 2 by 3 plus minus 5 into minus 2 by 3, and third will become 0. That is, third part is 0 into 1 by 3. So only 25 by 2 will be cancelled. That is 25 by 2 minus plus 5 to the 10 by 3. Consider 6 as LCM. Consider.
So 25 by 3.
25. Oh,
25
yes.
by 3.
So 25 by 3. It is 25 by 3 plus 10 by 3 as LCM. That is 35 by 3 will be the directional derivative of this grid phi in the given direction. This is the way to find out the directional derivative. Similarly, you can determine some another question for the directional derivative.
सर इसका एक और एग्जांपल करवा दो.
Directional derivative of phi, that is e raised to power 2x into cos of yz at this point in the direction of the tangent to the curve x is equal to a sin t, y is equal to be a cos t. This is the parametrical equation of the curve at t is equal to be pi by 4. Our aim is to find the directional derivative of this phi at the given point in the direction of tangent to this curve. Tangent to this curve. First, we find the vector equation of the curve, that is r vector equation of the curve is equal to be r vector is equal to be xi plus yj plus zk. Then tangent to the given curve will be dr upon dt. tangent to the given curve will be the dr upon dt. And if you understand what in which direction directional derivative is determined, then you can do easily. The solution will be, here we have given the phi is equal to e raised to power 2x into cos of yz. Then find the gradient of phi, that is I curl phi upon curl x plus j curl phi upon curl y plus k curl phi upon curl z. And determine the derivative with respect to x. E raised to power 2x derivative is twice of e raised to power 2x cos of yz as it is into I plus with respect to y e raised to power 2x as derivative of cos is minus, because in angle we have the y. The derivative of cos is minus sign, and y further derivative of yz is simply with respect to y is z. So it means it is equal to be minus z into e raised to power 2x sine of yz into j. And the for third part is derivative with respect to z, again derivative, consider the derivative of cos, that is again minus, and y e raised to power 2x into sine of yz into k. This will be the gradient of phi in general, but our aim is to find the gradient of phi at a particular point at 0, 0, 0, and replace x with the 0, y with the 0, and z also with 0. It means cos, because cos 0 is 1, e raised to power 0 is 1. So first one is 2i. In second one we have the multiple in y, multiple in z. In second one we have the z in multiple. So this will become the 0 to whole term. Similarly, in the third one we have multiple in y. So this will become the 0 to the whole term. So all other term will become 0. So we got this gradient of phi is just 2i at the particular point. Just 2i at 0, 0, 0. Now second thing is to be determined any direction, in which directional derivative is to be determined. So the given curve is r is equal to be xi plus yj plus zk. Then we have given x is x, y, z all in terms of the t. So that is equal to be a sine t into I, a cos t into j, a t into k. This is r. Now directional derivative is to determine the direction of tangent to the curve. To determine the tangent to the curve, so therefore tangent to the given curve is dr upon dt. Determine the derivative with respect to t. The derivative of sine t is just cos t. Derivative of cos t is sine t minus sine t. Derivative of a t is just a k. But this is to be determined at t is equal to be pi by 4. This is to be determined at t is equal to be pi by 4. Cos pi by 4 is 1 by root 2. Sin pi by 4 is also 1 by root 2. ak. T is equal to be pi by 4. T is equal to be pi by 4. Because our aim is to find the unit vector in this direction, so its magnitude is also required. That is equal to be a square by 2, then minus there is again a square by 2 plus a square under the root that is equal to be a square plus k, the a square, that is 2a square, that is a root 2 is the direct magnitude of this. Then unit vector, let it be n, that is unit vector in the direction of unit vector along the tangent to the given curve, at t is equal to be pi by 4. Therefore, I consider it is therefore unit vector n is equal to be dr upon dt divided by its magnitude, that is equal to be a into 1 by root 2i minus 1 by root 2i j plus k divided by a root 2. A will be cancelled and this root 2 will be multiplied, that is equal to be simply I divided by 2 minus j divided by 2 plus k divided by root 2. This will be the unit vector. Therefore, directional derivative is the directional derivative is equal to be gradient of phi dot with n. Gradient of phi is just 2i dot product with this vector I by 2 minus j by 2 plus k by root 2. Only I multiply with y, another will become 0. So only 2 into 1 by 2, that is 1. This will be the directional derivative of the given function in the given direction. This is the way to determine the directional derivative and other angles between the two वेक्टर्स. हमने जो एंगल बिटवीन द टू सरफेसेस के बीच में हमने पीछे लिया था, एंगल बिटवीन द टेंजेंट्स टू द कार, वो हमने पीछे डिस्कस कर लिया था. नाउ नेक्स्ट टॉपिक विल बी come to the next topic. The divergence of our next topic will be divergence of a vector point function. It means when this del operator, which we have already discussed, del operator applied on the vector point function in dot product, then it is named as a divergence. The divergence of a differentiable vector point function V is denoted by, that is divergence of V, and is defined as divergence of V is equal to be del dot V. This del named as a divergence here. When it is in dot product with a vector, then that del name is a divergence. That is equal to be I curl upon curl x plus j curl upon curl y plus k curl upon curl z into dot product with vector v. That is just simply because it is a vector v, the dot product is with v. That means with a vector, that is I dot with this vector, j dot with this vector, k dot with this vector. If this v vector is in component form, obviously the divergence of a vector quantity is a scalar quantity, because it is the dot product of the two vectors. Obviously, the divergence of vector point function is a scalar point function, because as we know that the dot product of two vectors is a scalar quantity. If this v is in component form, if this v is equal to be v1i plus v2j plus v3k, then the divergence of v, that is del dot v, is in component form, that is I curl upon curl x, j curl upon curl y, k curl upon curl z, dot with v1i, v2j, v3k. And in dot product, we only have the just dot product of I with I, j with j, k with k. All other will become 0 because of they are perpendicular to each other. Therefore, curl v1 upon curl x plus curl v2 upon curl y plus curl v3 upon curl z, because I dot I is equal to be j dot j is equal to be k dot k is equal to be 1, and another one is I dot j is equal to be j dot k is equal to be k dot I. All are equal to be 0 because since they are perpendicular to each other, and cos 90 is 0. So that's why the divergence of a vector in the component form will become this one, that is just the derivative with respect to x of the coefficient of I, derivative with respect to y coefficient of j, and derivative with respect to z coefficient of k. Next one is, because in vector product there are two type of the product, one is a dot product, another is a cross product. When two vectors are to be multiplied, then there are two type of the product. One is dot product, we consider dot product, that will become the divergence. If we consider the cross product between these two vectors, one is a del, another is v, then its name will become the curl. Its name will become the curl, that is curl of a vector point function curl of a vector point function, that is curl, or you can say the rotation of a differentiable function. And on the function, this is the condition that function should be differentiable, because we would like to consider the derivative of that function in dot product as well as in the cross product, because this del operator is a differential operator. This will be applicable only when this function will be differentiable. This function will be differentiable. This is the condition to find out the curl of a vector point function. The function should be differentiable vector point function. V is denoted by curl of V and is defined as that is curl of V is equal to be del cross V, and in cross product of two vectors. One is del, that should be in the first term. that is I, this one, J with this one, K with this one, cross product with V, vector V, it is equal to be I cross curl V upon curl X, J cross curl V upon curl Y, K cross curl V upon curl Z. This is a curl of V. Obviously, one can already aware about that when the cross product of two vector is also a vector. So obviously the curl of a vector point function is a vector point function. Is a vector point function. And if this V is in component form, that is V1i plus V2j plus V3k, then one can determine the curl of V is just the cross three minus curl upon curl Z apply on V2. Curl V3 upon curl Y minus curl V2 upon curl Z plus J multiply with, as in the second, consider this one, this, leaving these two. So first we consider the derivative of this one, first this one, then minus this one. That means in the second term we would like to open like this one, that is curl V1 upon curl Z minus curl V3 upon curl X. And similarly third one, for the third one again just like the first one, that is derivative of V3 with respect to X minus derivative of V1 with respect to Y. This is the cross product of two vectors. Just simplify the cross product of two vectors. Now let us consider some examples on to find out the divergence and curl of some vector. Example, if we have given the R vector journal xi plus yj plus zk, then evaluate. First one is, that is divergence of, first one is divergence of vector R, and second one is curl of vector R. These two are to be determined. Solution first, that is divergence of vector R. R we have given in the component form, that is del of dot R, dot product of two vectors. Del is, as we already aware about the dot product of these two is just with respect to X, V1 of with respect to X plus V2 of with respect to Y, V3 of with respect to Z. Just consider that part only. We have X is equal to be, R is equal to be Xi plus Yj plus Zk. So it is equal to be curl of curl X with respect to X plus curl of curl Y with respect to Y, curl of curl Z with respect to Z. That is equal to 1 plus 1 plus 1, that is 3. Hence divergence of vector R is equal to be 3. You can use this divergence of a vector R journal, that is equal to be 3. Now second part, curl of vector R is to be determined. Curl of R, that is del cross R, that is equal to be I j k, curl upon curl x, curl upon curl y, curl upon curl z. This is x, y, z. Expand this determinant using the first row. That means we consider the derivative with respect to this. That is curl z upon curl y, which is equal to be 0. Similarly, curl y with respect to z, that is also equal to be 0. And j will be curl x upon, curl x upon curl z minus curl z upon curl x, that is also equal to be 0. And third one is k is curl y upon curl x minus curl x upon curl y, that is also equal to 0. All third term will become 0, that is, it is a 0 vector. It is a 0 vector. That means curl of a vector R is equal to be 0, can be used anywhere in the successive questions or examples. And curl of a vector R is equal to be 0 and divergence of a vector R is equal to be 3. You can determine like this another question on the basis of the curl and the divergence of a vector. Let us consider one more example of the some different type, that is let vector R is equal to be xi plus yj plus zk and A be a constant vector. Find the value of divergence of A cross R divided by R ki power n. This is a vector quantity because in denominator we have R ki power n, that is R, simple R is the magnitude of vector R. In numerator we have a vector quantity, so it complete will become the vector quantity. So divergence of this whole term is to be determined. Let us consider the solution. Here we have given R is equal to be xi plus yj plus zk. This implies simple R will become, that is magnitude of this R, that is x square plus y square plus z square raised to the power square root 1 by 2. And let vector A, which is a constant vector, a1i, a2j, a3k, where a1, a2, a3 are constant, where a1, a2, a3 are constant, because the whole vector A is a constant vector. Then A cross R to be determined first. A cross R to be determined first, then consider R raised to power n. Find the A cross R, therefore A cross R vector is equal to be, it is I, J, K, A is A1, A2, A3, R is X, Y, Z. Expand this. Determinant, which is equal to be I with A2J minus A3Y into my I plus J with A3X minus A1Z into J plus K with A1Y minus A2X into K. This will become the A cross R vector. And simply A cross r vector divided by r की power n. Just divide the whole term will be with x square plus y square plus z square raised to the power n by 2. Because r is raised to power 1 by 2, r की power n will become n by 2. Numerator we have the same as we have written above, a2z minus a3y into I, a3x minus a1z into j plus a1y minus a2x into k. Now just simplify, just evaluate the divergence of the vector. Divergence of this vector a cross r divided by r की power n. That means del dot with this vector a cross r divided by r की power n. When our aim is to determine the dot product of two vectors in component form, just multiplication of the I coefficient of i's plus coefficient of j's plus coefficient of k directly. So it means we have already aware about the del. What is del in component form? That is I times of curl upon curl x plus j times of curl upon curl j y plus k times of curl upon curl. I should write directly, and with respect to x of the coefficient of I, that is a2z minus a3y divided by x square plus y square plus z square raised to the power n by 2 plus with respect to y of a3x minus a1z divided by x square plus y square plus z square raised to the power n by 2, and third with respect to z of a1y minus a2x divided by x square plus y square plus z square raised to the power n by 2. This one. Now consider the derivative of each one. Consider the derivative of each one. First derivative of this with respect to x. In numerator, there is no term involving x. It means it considered as a constant. Only the derivative of the denominator. So for considering the derivative of the denominator, first we consider the raised to the power minus n by 2, and if derivative of the power minus n by 2 into whole raised to power n by 2 minus 1, then into the derivative of this x square plus y square z square, which is equal to with 2i's of x. Similarly for the next one and third one and third one, the derivative will become, that is, because a2z minus a3, I consider it one by one. I consider this whole term as a one by one. Then I keep all these values in this equation. First you determine the with respect to x, a3y x square plus y square plus z square raised to the power n by 2. Because in numerator we have no term involving x, so only the denominator involving x. So in the denominator, consider in the numerator that raised to the power minus 1 by 2. That means its derivative will becomes a2z minus a3y is a constant. Derivative will becomes minus n by 2 into x square plus y square plus z square raised to the power minus n by 2 minus 1 into the derivative of x square plus y square plus z square with respect to x, that is only 2x. Only 2x. Just in simplification, this 2 will be cancelled. This 2 will be cancelled. And remaining will becomes x into a2z minus a3y divided by x square plus y square plus z square raised to the power n by 2 plus 1. Similarly, the second term will be, similarly, I write the second term and third term is similarly. Second term a3x.
सर माइनस n रह गया.
we require, yes, minus n is there also there. Similarly, second term will be a3x a1z divided by x square plus y square plus z square raised to the power n by 2. That will become minus n y into a3x minus a1z divided by x square plus y square plus z square raised to the power n by 2 plus 1. And third one is with respect to z, that is a1y minus a2x divided by x square plus y square plus z square raised to the power n by 2 is equal to be minus nz into a1y minus a2x whole divided by x square plus y square plus z square raised to the power n by 2 plus 1. Substituting all these values in the star, putting all these values in star, what we get that is divergence of a cross r divided by r की power n will become minus n as a common, and one more term is considered as a common, that is x square plus y square plus z square raised to the power n by 2 plus 1. This is also considered as a common. From the remaining, what will happen? Then this multiply with this x, that is a2xz minus a3xy minus a3xy plus a3xy minus a1yz, and third term will become plus a1yz minus a2xz. This will be the complete. a2xz will be cancelled with this term, a3xy cancel with this term, and this term will be cancelled. It means complete 0. The right hand side will become 0. Hence, the divergence of a cross r divided by r की power n will become 0. It is a scalar point function because dot product of two vector is a scalar quantity. So it is simply 0. This is the way to determining the divergence of a different type of the function. Divergence of a different type of the function. मेरे ख्याल से और एग्जांपल लेने की जरूरत नहीं है. दिस डाइवर्जेंस एंड कर्ल के आप सिंपली निकाल सकते हैं. Now we consider the physical significance of the divergence and curls. Physical significance of the divergence of curl. I just mentioned directly what it gives. You should do the proof of these two also. Physical significance. मैं डायरेक्टली बता देता हूं कि फिजिक्स क्या देता है. ये आपने करनी है. ये यू शुड डू योरसेल्फ. डाइवर्जेंस ऑफ ए वेक्टर v gives the rate of outflow per unit volume at a point of the fluid. आपने हो सकता है आपने 11th क्लास में जब भी वेक्टर पढ़ा था वहां पर भी पढ़ा होगा what is the physical significance of the divergence, how to evaluate this. यानी ये क्या देता है, रेट ऑफ आउटफ्लो पर यूनिट वॉल्यूम एट ए पॉइंट इन मीन्स दिस इम्प्लाइज। तो अगर इफ वी हैव द डाइवर्जेंस, अगर आपके पास में डाइवर्जेंस ऑफ जीरो, डाइवर्जेंस ऑफ वेक्टर जीरो हो एवरीवेयर in some region, R of the space, then this vector V is called a solenoidal vector. It means if we have given the given vector is solenoidal, it means the divergence of that vector it will become zero. Solenoidal vector point function. अगर कोई वेक्टर दिया हुआ है कि ये सोलेनोइडल है, इट मींस उसका डाइवर्जेंस जीरो है। अगर ये कहा हुआ है कि डाइवर्जेंस ऑफ जीरो है, डाइवर्जेंस ऑफ वेक्टर जीरो आता है, इट मींस दैट वेक्टर इज नेम्ड एज ए सोलेनोइडल वेक्टर। नेक्स्ट इज द फिजिकल सिग्निफिकेंस ऑफ द कर्ल। हमने ऊपर मेंशन भी किया, जब कर्ल हम मेंशन कर रहे थे हमने कहा था कि इट इज आल्सो नेम्ड एज ए रोटेशन। तो क्यों था? क्योंकि ये आपका एक रोटेशन देता है, द एंगुलर वेलोसिटी, एंगुलर वेलोसिटी at any point is equal to half the curl of the linear velocity at that point. Body. That means this is omega is the angular velocity. It is equal to be half of the curl of v. If at this angular velocity, the angular velocity at any point is equal to, this is the angular velocity, omega is the angular velocity, is equal to half of the curl of linear velocity at that point. This v is the linear velocity, curl of this v will become the twice of the angular velocity of that point of the body. And similarly, we consider a remark of this, because as we determine the physical significance, this curl of v will give us the rotational, any rotation we give the rotation angular velocity. It means if curl of v is equal to a zero vector, because cross product of two vector is a vector, then this v is called an irrotational vector, otherwise rotational, यानी किसी वेक्टर का कर्ल अगर निकालें वो जीरो आता है तो वेक्टर इरोटेशनल है, यानी उसकी एंगुलर वेलोसिटी जीरो है। ठीक है, अगर वो नॉन जीरो है इट मींस वो रोटेशनल है, इट मींस वो रोटेशनल है। Now let us consider some properties of the divergence and curl. Sometimes when this del applied on the vector in cross product, it will become the curl. When it applied on the vector at a dot product, it will become the divergence. So we define some properties of the properties of divergence and curl. स्क्रीन शेयर हो रही है? हेलो,
हो रही
am I
है
audible?
हो रही है सर
स्क्रीन
Yes, sir.
शेयर हो रही है
Yes.
स्क्रीन?
Yes, sir.
Let us define the properties of the divergence and curl. First property, for a constant vector A, divergence of a vector A is equal to 0, as well as curl of a vector A is 0 vector for the constant vector. Second property, that is divergence of sum of two vectors is equal to the divergence of sum of their divergence. That means del dot A plus B is equal to B del dot A plus del dot B. Dot product is to be distributive. And third property is, that is curl of A plus B is also equal to B, that is curl of A plus curl of B, that is simply del cross A plus B is equal to be del cross A plus del cross B. And fourth property will be, if A is a vector function and phi is a scalar function, then divergence of phi times of a vector A is equal to be phi times of divergence of A plus, when this del, because this divergence is a del operator, when this del applied on the scalar point function, it will become the gradient of phi dot vector A. Or you can say that is del dot product with phi times of a vector A is equal to be phi times of a dot product of del with A plus gradient of phi dot product with A. This is the fourth property. Now fifth property is, if A is a vector, A is a vector function and phi is a scalar function, then curl of phi times of a vector A will become, that is phi times of curl of A plus gradient of phi cross product with A. Or you can say del cross phi times of A is equal to B, that is phi times of del cross A plus gradient of phi cross product with vector A. Sixth property is some different type. Sixth property is del of A dot B. Because dot product of two vector is a scalar quantity, so this del is a gradient. Gradient of A dot B will be equal to B A dot del into B plus B dot del into A plus A cross del cross A, B, and similarly last term will become B cross del cross A. Generally we know that the dot product of two vector is commutative. Dot product of two vector is commutative, but in this case, that is A dot del is not equal to del dot A. This point to be noted down, because A dot del is not equal to del dot A. Why it is these are two not equal? This del applied on A. This del applied A. But here del operator applied on the successive terms at B. First considering the dot product of these two, then the differential operator applied on B instead of A. So this implies the A dot del is not also. This property is some different type. You should remember it. Similarly, let us consider the next property, that is seventh property. It is del dot A cross B is equal to B dot del cross A minus A dot del cross B. Or you can say, you can also write in the form of divergence of a curl, because it is a dot product. Divergence of A cross B will become B dot curl of A minus A dot curl of B. This is the property of the divergence of A cross B. And last property of this is, that is del cross of A cross B, yani vector triple product. Vector triple product, in the definition of vector triple product is different, but whenever this del is applied on this vector triple product, in that case it is different. That is del dot B into A minus del dot A into B plus B dot del into A minus 8. ये दोनों प्रॉपर्टी आपकी थोड़ी सी ज्यादा टेंशन की रिक्वायरमेंट है, बाकी प्रॉपर्टी सिंपल है. यू कैन डू लाइक दिस. ठीक है. ठीक है भाई.
Thank you, sir.